Ma'am, we are live now, ma'am. Please start.
Thank you. Shall I get started right away? How do you want to do this? Balaji, shall I just go ahead and start?
Yes, ma'am. Please, ma'am. Yes.
Okay. All right. Give me a minute. Okay. Hi, everybody. My name is Saritha Route, and I'm an IBM Distinguished Engineer. My passion and my focus is AI and automation for testing and quality engineering. I also run the Automation Innovation Center here, and I basically focus on driving new research technology into quality engineering and automation. Okay. So today I'm going to be talking to you about AI testing and what it takes, why is it important, and where is it going? All right, that's the context of this talk. Now I will go ahead and share my screen and run you through a few slides to explain this context to you. Okay, I hope you can all see my screen. Right? So we're going to talk today about the AI tester and who this AI tester is, or what this AI tester is, and what it entails. Okay, the whole idea is about extending quality engineering into the AI infused applications that are becoming quite the norm these days. Okay, so we will cover three things, and my session is going to be structured in three ways. We'll talk about the importance and why AI testing is coming to the forefront today. And then we will talk about how we do AI testing, or what is required with respect to AI testing to drive business outcomes. And then we will do a quick wrap up. Okay. So let's jump right in and talk about the importance of AI testing. So this slide over here shows you about a recent study that was done by the IBM Institute of Business Value, which showed how technology and technology adoption has changed pre and during COVID. And what I would like you to focus on, this very important piece, right, where you see artificial intelligence gaining great momentum along with mobile and cloud over just this 1 year of COVID. And I'm sure all of you have seen it yourselves. You've seen more and more AI applications, more and more chatbots as an example. I mean, something even as simple as chatbots, right, have gained a lot of prominence, and businesses are expecting a lot of value. Businesses are expecting to drive business outcomes with AI technology and analytics of different kinds. So all of this means basically, whether it's conversational systems, recommendation engines, different kinds of AI-led workflow processing solutions which drive business outcomes, will require, for it to provide those outcomes, require to be tested thoroughly with a focus and a lens of quality engineering, which means bringing testing and bringing quality into focus upfront rather than at the end. Okay. And it's interesting because it's not just this unprecedented adoption, right, or the wave of adoption that's happening, but it's also the fact that as such, when you look at the AI applications in the market, there have been three things that have been inhibitors in its large-scale adoption in providing great business value. Data itself that goes into the modeling, skills of the practitioners on the ground, and performance of the models overall. So obviously, when you look at these three things in conjunction and the fact that the business needs it, testing and quality come to the forefront. So let's just take a look at the vastness of this AI-infused application landscape. So AIIA is the new four-letter acronym in this case for defining applications that use business applications that use AI at its heart to drive the business outcomes. And if you look at it, you have different kinds of data that goes into it, right? Structured data, unstructured data. There are different modes in which this data is even input into the systems or ingested and used. And of course, there are core algorithms, right? Which are again varied, different, and continuously being used in different forms. And all of these come together to basically build out AI-infused applications, which range from conversational services and chatbots, speech-enabled solutions, image analysis, visual analytics, search and image classifiers, natural language processors, intelligent workflows to drive business outcomes, and also AI that uses human in the loop, right? AR, VR, improving our lives in many ways. So there is a lot that happens here, be it real-time decisioning, as in a financial forecast or a weather forecast, or an image classification, like even a customer segmentation. What are you going to buy? What will you buy along with the bread that you have bought on the online grocery store? Right? What are people typically doing? How can you be incentivized to buy more or give you targeted marketing? Right? Analysis of a shopping cart, sentiment analysis. Are you a happy customer? Are you likely to buy more? Are you disgruntled? Do we need to change the way in which we approach you? Right? These are all the kinds of ways in which we are using AI to actually reach out and drive greater business outcomes. And even to run our own businesses, right? Be it the way we handle customer support, the way we reach out to clients. So all of these come together. So if you just think about it, it's mind-boggling, right? And how do you establish a common construct of quality? How do you understand the quality and what is required? How do you bring about explainability of the solution? So there are multiple questions, right? How do you understand the quality of the data that goes into the model? How do you know that data is good enough? How can you supplement it? How do you measure the accuracy consistently? What should be tested, right? Do I only test the model? Do I test the system in conjunction? How do I make sure that it's going to drive the business value? So, which means, how do I know what test cases to write and whether my tests are providing the right coverage? Performance of the AI ML components, that's a pretty interesting area, right? Because if you would talk to a data scientist, it's all about accuracy and bias handling. You talk to a tester who's used to handling large systems, they'll tell you it is about how the system performs in production, or how the system is supposed to perform in production, or how it is performing with respect to the business requirements itself, what the business needs. How is it performing in conjunction with the entire application? Right? So there are definitely different questions here that need to be asked, and they are all fundamentally driving quality. If you ask the right questions, you will get the right tests and you will build the right quality. Okay? And this applies to all types of AI solutions. So we are not being biased here. Now, when we look at the AI landscape, right, we said it's vast and it's huge, and we need QA at the forefront. So let's take a step back and say, what do we have to work with as a quality engineer, right? We will have the data, of course, we will have the model itself, and we will have the business requirements. And it becomes our job to synthesize these independently as well as in conjunction to provide the right kind of test and quality engineering focus. Okay. So if we were to look at a conversational system, a chatbot, right? What do you expect from it? You want that as soon as you either type out or talk to the chatbot, it is responding to you with speed, right? That it's not left you hanging. So you want fast response time. You want that as a business, you want it to be fair and consistent repeatedly. It's not necessary that the chatbot has to be always accurate, right? Or 100% accuracy is not the aim here of the game, but is it doing its job more number of times than not? Because remember, it all ties back to the business outcomes, and we'll talk a little more about that. Other aspect is, of course, accuracy of the response. We touched on that. How does it actually handle voice? How does it handle text? What's the conversion accuracy? Right? So these you will start seeing as you work through the different kinds of AI-infused applications and solutions, you will see that different things come to the forefront, but definitely response time, performance, sentiment analysis, context relevance, right? Accuracy, prediction of the accuracy of the prediction, the data quality assessment. All of these become extremely important. And as you drive through more integrated business solutions, integration compatibility, the way it is provisioned to the client becomes important. And while we don't put this on the slide here, performance becomes an overriding construct, right? We've not got, when I'm talking about response time, performance construct does come in. But we're looking at performance in a different angle. Like I said before, a data scientist will have a certain view, a tester has a different view. And here we'll talk about other kinds of non-functional requirements, right? How is it usable? Is it giving a right experience, right? All of these also start coming into the play because fundamentally, a lot of things are changing. AI solutions are no longer back office solutions. They are there up front and personal and close to the end customer as well, right? So very often it becomes the very first touch point that a customer has with the business. So the experience is really important. So this is just a sample application, okay, of an AI-enabled system. This is one of our own applications where we do defect classification and analysis. And the most important part about here is that, you know, there would be a series of inputs either pulled in from the system itself or the systems that it integrates with, or there, and it would also have certain inputs which are manual or user-driven inputs. And then there is a whole classification that comes into play. Now, it's interesting because if you look at it, we talk about, you know, what's the percentage of confidence with which this classification is being done? And that becomes an important aspect because remember, as testers, we are used to certain things being black and white, right? A response has to be, you know, when we typically test traditional systems, what do? We have an expected outcome, right? And we expect that that expected outcome is always presented. Otherwise, the test has failed. Now, in this particular case, there is a construct that the test has passed as well as it's partially passed. If the confidence is not adequate, then it still has provided a response. It's just that it's not within the response ranges that are required, right? Or it is something that we desire to be improved. So these are very interesting constructs which bring us into a gray area of testing, an area of testing which is basically about testing probabilistic, non-deterministic systems as opposed to traditional software solutions. So that's the context. Now, with that context, you can understand that there is a lot of need, right, to bring quality into place. And there are a lot of challenges inherent. So how do we actually look at this and deconstruct it? So let's look at what are the goals, right, of any AI component in a software solution, right? What does it come to? Aim is to automate any existing tasks. So there's a translation to be done. There's a job to be done. Is it automated, right? A response to be given. It could be about improving the efficiency, right? Like the previous classification system. If it gives me a classification and a response already, then I don't need to spend a lot of time to analyze and wonder and figure out whether I've got the right thing. I just need to validate what is there. Or it does, you know, gives me data, gives me insights that I can use, for example, to be able to perform my job better. So as an example, this is a lovely system that we use internally in my own organization, where I get recommendations about promotions, about salaries, and they're recommendations based on, let's say, going to different systems and looking at a person, an employee, in a holistic manner. And then giving me as a manager recommendations that I can use, discard, apply more knowledge of the person on, and either accept, reject, use it in whatever way I want. It's not superimposing anything on me, but it's pulling and giving me all of these insights that I can use to do my job better. It allows me to perform new tasks as well. Okay? So these are primarily the goals of any component solution in terms of software system, an AI component in a software system. So what then does it mean, right? Now, we are testers, most of us here. We understand software engineering. We understand quality engineering. So it's a very simple aspect. Let's look at the requirements, make sure it's translating to providing the right process outcomes or adequate process outcomes using the right or fit for purpose data and providing a good user experience. I hope you're with me so far. Now, let's go a little further. Now that we've understood the goals, let's understand how AI components fit into a software system. So if you look at it, your UI, your customer database, all of those are traditional, your automatic, your software systems that we are familiar with. Now you start bringing in aspects like the ML insights. You bring in natural language processing, you bring in a chatbot on the corner of your screen, you bring in a data model or a deep learning or an image recognition solution. You bring in some business process rules, some intelligent hyperautomation solutions. And there now you have an AI infused application. And internally, they can use different techniques. They can be using different aspects of deep learning. But to you, it is an application software where you as a user are interacting with, or subsystems are interacting with them, right? If they are built into a workflow to provide certain advanced outcomes like we talked about before. So how does it look, right? How does this change? So in a nutshell, if we were to look at it, we are saying an AI-infused application is an amalgam of cognitive enterprise capabilities. Right? So your engagement channel can be your normal web front end, a traditional UI. It can aim to give you an omni-channel experience, irrespective of whether you pick up the phone and talk to somebody, you go to your mobile, you go to some point of sale device, you go, right? You walk into a store and there's a camera recognizing your face and pulling out your order. It could be a bunch of these different engagement channels that are there, right? And as a result, you now come across, it could be a chatbot as well, right? So you now come across an AI-infused interaction that is now being provided. Similarly, when you go into the business platforms layer, right? Whether it's SaaS, enterprise applications, bespoke solutions, today, all of them invariably have some AI components built into them, providing some intelligence or some better experience, or improving the way the task is done. All of these in turn interact with core systems, plus they may interact with core AI frameworks and models themselves, performing additional functionality. And of course, there's the analytics and reporting engine. All of this based on different kinds of databases, file systems, and deployed by means of hybrid cloud deployments, right? Provisioned on cloud typically. So when you look at these architectural elements, you now understand that if we were to look at the system holistically, when I'm testing an AI-infused application, it's not just about testing the model, but it is testing the different AI elements that come in throughout the reference architecture that we have, the solution architecture that we have, and enabling the right outcomes at every level. So it really gets interesting and poses interesting challenges to us as testers. So let's look at how solutions are built, right? Now, when we look at it, the requirements go into a solution design and solution architecture and design. Now, at that point, we actually segregate and say, well, this is the non-AI component. These are the interfacing systems, the front end, the back end that needs to come into play, needs to be built anew, or needs to be integrated with. And then you have the AI model itself that needs to be built out, the algorithm and the code. Now, this is a very interesting trifecta, right? Because to build that, you actually use AI frameworks that are available, and you use training data to build this out. And this goes through multiple churns and becomes a typical, though data scientists won't like me calling it typical, but it becomes a build activity, right? Where there are iterations, there are corrections, there is a lot of understanding in terms of what is being done and what needs to be done. So here, there's a slightly different focus in terms of how the data scientist would look at it, and how as a tester, we need to be hooked in on that process to understand what is going on. Then of course, these two components come together to build out the AI-infused application, and we put it through a regular rigor of test data or even system data that can be used to run this solution or be driven by the solution. And then of course, this goes out into production, where actual users or actual production data comes into play. And it's very important at this point to actually monitor those business results, monitor the usage, monitor the data, monitor the responses, because all these AI-infused applications, the AI component at the heart of all of this is aimed at providing an invaluable business result. And that could be, for example, let's take the example of the chatbot, right? Because that's the easiest. All of us have interacted with chatbots at some point or the other. It's about being able to provide the right responses more number of times than not, right? At least 80% number of times you need to have resolved the problem at the chatbot level. Right? You don't want to be handing over to an agent for every single query, because then the business is not getting value. You want to reduce the human element to address standard queries, right? And standard business processes. So that's why it's important to see, okay, how is your model performing out there in the wild and what is happening? You get an assurance by putting it through a certain test rigor all through the cycle, right from requirements. So let's look at the three types of, the focus that we bring into the testing here. So of course, it's all about understanding the solution needs and designing for it. So here, a lot of focus goes into understanding the data and preparing the data, whether it's cleansing the data, analyzing the data, profiling the data, validating the data. All of these are traditionally and typically functions and tests that the data scientists themselves will do. Now, as testers, we do need to also understand the data, because we need to know how is the data being given to us? How does the training and the test data look? Have we done a profiling across them to understand what they are? If I have to augment and create new data, do I understand the profile of the existing data itself? Right? And next part is about bringing in early statistical measures to validate and get a better understanding of the data. The next aspect would be in terms of business context integration and driving test cases, identifying test combinations that are required to test both the model in the as well as the model in the context of the business. Okay, we've talked about it a lot, so I think I'll just reiterate with one point, which says that, remember, this becomes extremely important when you start defining your test cases here, because these are probabilistic systems. Right? So if you know that there are only two paths, right? As a tester, you know, okay, let's test path A, let's test path B, right? Let's make sure that if I give the right inputs, I will not go to path A. And if I give the wrong inputs, I will not go to path A. And if I give the wrong inputs, I will not go to path B, right? So it's very clear. You've tested the positive scenarios, you've tested the negative scenarios, and you know your coverage is complete. But here you need to now extend constructs that you've learned, typically boundary value, equivalence partitioning, and see how do you actually scale it out to understand your data, which is now going to be the prime driver of your test cases, so that you can create the most representative tests that provide coverage on the model, as well as provide coverage from a business angle. So the next aspect, and that needs to be done earlier rather than later, because otherwise you will never have time to establish that coverage, right? You'll never have you'll never gain that right understanding. The next part is in terms of during the build and validation phase. Data profiling takes on a new dimension, and quality of that data, which has been cleansed, which has been standardized, the data stewards have gone and got it modified. And also another interesting thing that happens is during the build process, the training data itself is undergoing many changes. There may be different versions with respect to the intermediate models that are being built out, right? You don't need to be hooked in as a tester on all of that. That's the data scientist domain, right? Keep your focus on how your test data is looking, yeah, and start determining how that data will be spliced, what greater intelligence can you get from that data so that you can add more business tests and enhance your test coverage. So here, early AI performance testing can be done on the model itself to give you some model validation, as well as give you performance indicators in terms of bias, accuracy, sensitivity, robustness. And then when you go into the actual, when the systems are delivered to you, when the components are ready and ready for integration or already integrated, you now do data setup for the test scenarios that you have already identified. And this becomes interesting because you want to have fit for purpose data. So let's take a very simple example, right? Your system is basically classifying and identifying cats, right? So as a tester, you need to make sure that you have cats of different breeds right? Different colors, different, big cats, small cats, sizes, and then maybe domestic cats, wild cats, different types of cats. Then you need cats in different actions as well. So, but what you really need, and maximum of your training is around saying, can this system actually identify the cat? So give it as many different types of cats as possible. Okay. Now at this time, populating your data with a whole lot of, let's say, zebras is not going to help. Yes, it will help that your system is able to say, this is not a cat, right? But you want, I mean, in this context, you want it to actually be able to say, can it identify the cat, right? So I'm giving you this very crude example because I want you to understand that data has to be fit for purpose, fit for that business scenario to give the right value. And you need to, of course, test with data that breaks these bounds. You need to be able to see what happens when you flip this around, right? What happens when you bring in adversarial conditions? What happens when you change the feed, right? Change the data. Is your model too sensitive? Does it address this gracefully? Is it robust? How does it perform, right? So those are things that you definitely need to look for. But the whole idea is it's fit for purpose. And then your next thing that you're focusing on here is business test validation with and without the ground truth. Again, coming back to the point that I'd made earlier, which was about saying that as testers, we know there's an expected result. So let me test for that expected result. Okay, that expected result, when we talk about AI testing, becomes what is known as the ground truth. Okay, so if I know that following certain criteria, certain data setup, I will be given a loan, perfect. So Saritha will be given a loan, right? So, and you know that data, you know the characteristics, you know the profile, and you know that she should be given a loan, right? So it becomes that, and so if the model doesn't provide the loan, you know that it's not doing its right job. Or if you change some characteristics and it gives you a slightly different response in terms of the assurance or the confidence, you know there is a, you can measure whether it's being robust or it's highly sensitive. You can identify those aspects. So here the ground truth becomes essential. But what happens if you don't have a ground truth? How are you going to test? How are you going to validate? How are you going to know that, okay, this is the right answer it's supposed to give, right? It is supposed to give Saritha a great credit score and give her a loan. You don't know that, right? So this is where statistical analysis, you need to basically run different kinds of tests that measure the responses and look at doing statistical analysis on those tests and those reports that are generated. You need to have sufficient volumes of data with sufficient variations that are fit for purpose that will allow you to understand the structure, the responses, and gain patterns from it as well. And then based on that, you will start changing your test cases or modifying your data to see how the system is responding and whether it is moving forward. So you start growing your tests even as you proceed, yeah? And you learn as you go. But for you to do that adequately, right? Just like your data is fit for purpose and fit for the scenario, right? You need to understand the business. You need to have domain skills. You need to know what it is that the business wants out of all of this and what are the key factors and parameters that are going to influence those decisions. Yeah. So an interesting piece. So there was, I mean, if, for example, I want to be able to, predict how many tickets are going to be sold on an airplane, as an example, if I don't consider a holiday calendar, right, I'm going to get a very wrong prediction, right? So that's where the domain needs to come into play. What are the key factors that influence the solution? And that, as a tester, you must be cued on. And where will you get that information? Going back to the requirements, going back to the domains, connecting with the business. The last part, of course, is in terms of using metrics that will validate performance. And we talked about performance, not just in terms of bias, sensitivity, robustness, but also in terms of performance of consistency. How often am I getting the right kind of response? So these are some ways in which you would actually deconstruct the work that you normally do as a tester and take it forward. Okay. So that's nice to hear, but what typically happens in build and deploy, right? Now, usually what happens is that there is the traditional approach, right? And this is the pre-understanding that we need to bring testers into play, is that there's a whole iterative process of definition, low traceability, low solution veracity and coverage. What happens is that there's a data exploration, there's a data gathering phase, analysis of the data, cleansing, transformation, then feature engineering based on the key factors that are identified, the model building, and then of course you're supposed to communicate. So that's a lovely streamlined manner. But that's not how it always happens. So sometimes from gathering, you'll go into cleansing because it doesn't give you the right insights. And then you do some data analysis, you do some model building. This is what the data scientist does, right? As a part of their work, do some feature engineering and build out a system. So it's all very traditionally what's been happening, because it's been a new field. There's been a lot of exploration. It's been considered, and rightly so, quite an art form in some ways, right? So because you are creating a solution without really being able to define what the outcomes are, because it is non-deterministic. It's a recommendation. You know what the recommendation should do, but what should the combinations, what should the influences be? And those keep changing as you understand the data better. So traditionally what's been happening is that you do the model building, you do some kind of unit testing, fix that, deploy it. Then from the deployment, you go back to fixing the model, do some more building of the model, do some unit testing. So it kind of is a little bit of, unit testing at one hand, and then a lot of testing being done at the business end. Not a good story, right? And that's one of the reasons why till last year, adoption of AI at scale in solutions was comparatively low. Companies were not finding adequate business value, were not realizing adequate business value from the spend on building AI infused solutions. In fact, what's also been happening, businesses have been grappling with graveyards of models, right? As models don't do what they're supposed to do in production. And that's where, again, I would reiterate, comes in this great structured focus that we as testers know how to bring in. Yeah. So we propose a complete start left approach, right? Do your data quality analysis, do the transformation, build out the model, generate test data based on the profiles of the training data that you know, right? Debug, localize errors in this, identify possible weaknesses, feed that back into the model. Now, all of this has to be automated because otherwise it cannot be done at speed, right? So you need tools, you need techniques, you need statistical analysis and controls that allows you to do this. Then once this is done, you need to be able to bring in and the model is built out, you need to actually say, okay, what are the application validation that I need to do, or the business tests that I need to run? Okay. Again, this is not going to be possible if you don't do two things. One is get the insights from the data itself and marry it up with the business requirements and have a core understanding of at least a high level understanding of the AI components in the solution. That is what you would then drive as an automated test. Again, because of the sheer volume, right, of tests that you would need to run, you do need to look at an automated way to do this. And then you're able to deploy the model and validate it. And when feedback comes in, you're at least assured, because you've done it in a structured manner, that it's not going to be too off the base when it goes into production. And you've measured all through, and we've covered all those measures as we moved forward. So how do we approach all of this? This is all good stuff. How do we do it? Right? So the whole thing is to first start with data. Profile data to be fit for purpose. Use statistical controls. Understand the construct of the data, the dependencies, so that you're able to build out your test cases with that knowledge and that intelligence. Use data insights around key factors. Like I told you, if I don't know that there's a holiday calendar that needs to be ingested, I'm not going to be testing the model, right? Yeah. So use key factors and data insights around the key factors to be able to do feature engineering. So for example, holiday season in India may be different from what's in the US. And you need to understand then there's more data, that it's not just the holiday calendar, it's the regional that you need to look at. Then the next aspect is learn to test the APIs and the consumed components. So you have to distinguish, and this is where you'll start testing the model itself. right? You don't need to wait for the entire system to be provisioned to you. You start testing the model in an iterative manner, using data that you transform and feed to it to test its accuracy, fairness, bias, play around with the data. And all of this has to, again, be automated, because otherwise you're not going to be doing it. So as an example, let's say you have a chatbot which you're typing and interacting with, right? Does it, for example, recognize typos? Does it handle typos well? Does it handle regional colloquial conversations? Okay. Does it understand business specific aspects, right? In terms of, you're logging into it and asking about a certain product with a product code. Is it equipped to handle those codes, right? What happens if you turn that around? What happens if you introduce profanity? Does it handle that well? What happens if you introduce different kinds of noise, put cricket scores in between? We've done that as kids when we were doing our exams, right? And we had to write essays, okay? Right? You put a little bit of a story in between. What happens? Does it handle that well? So those are the ways in which you actually test the system and put it under stress to validate its accuracy of response, fairness, sensitivity, robustness. How is the model performing under all of these when you change the data around? Then, of course, you go and test the solution as a software. So this is about testing functionality, performance, experience, business outcomes. Okay. So how do we do this? How do we break this down? So we built, so typically the way we need to do this is to first understand and access data. So you need standardized tools and solutions that will give you insights on the data, the quality of the data, the profile of the data, the interdependence. Right? Then you need to develop functional tests for which you should use techniques, advanced techniques like optimized test design or combinatorial test design, to understand the different paths and different flows that the business application takes, and also understand that in conjunction with the data. Generate more test data as the case may be, based on what you're seeing as error concentration, possible error concentrations based on statistical analysis of the data itself. Okay. And all of these you need to build out or have access to tools that allow you to do this by default, because these cannot be done manually and they need to be done in a structured manner. Okay. Now you validate the AI model by running these inputs to it directly, right? So it's all about, you've set up your tests based on the data. Right? Now this becomes interesting because it's, while you can feed your data in to the model directly, testing the APIs, testing the responses that you get, it comes to a more interesting space when you go into an end-to-end test space, right? And that's where you integrate it with your existing automation tools, right? You use Selenium to run the business processes if it's a front-end driven system, or you use Appium, and you integrate these feeds and these test scenarios, and you go back to all those business validations that you drove and have those tests automated that you can run into the model. Then, of course, test for performance, user experience, and so on. And most importantly, don't forget, these are probabilistic systems. You need to evaluate the results and you need to understand the metrics so that you can now go back, build new tests again, especially in cases where you don't have the ground truth. Okay. So what are the considerations during build and test of AI solutions? Remember the challenges that you face and the developers facing, right? The data scientist. It is about managing the data and the AI cycle. So there will be a lot of data that is being built, temporary models being built, then they go back, get more clarity on the data. Unfortunately, like I shared before, it's not a totally streamlined process, right? And then the more important aspect, and this is a real challenge, which is isolating error behavior. Is the error because of data? Is the error because of the model? Is the error because of the framework that you're using? How do you identify that, isolate it, and fix for that? At the testing side, it is more about how do you generate tests and data that provide coverage. It's a probabilistic system again, so you need to look at coverage in different aspects. Working without ground truth, we covered this already. And most important, a big concern that is usually a pushback in terms of when to include quality engineering and testing is about isolating and managing defects. So a data scientist would typically come and say, well, you've used, when you raise defects, you need to have as a tester a right understanding of the system, right understanding of what the system, what algorithms are being used at a high level, if not at depth, so that you can say that you are raising the right kind of defects and you're maintaining the right kind of defects as the fixes also come in. Because if you need to be able to provide very pointed insights back to the data scientist with metrics to tell them that, yes, the data is fine, or the data is not, or it's handling profanity, it's not handling profanity. You need to be very specific, right? So those are some of the aspects that you need to look at. I've been using a very, very simple example so that you can understand different ways in which we need to start communicating the very specific aspects and not get befuddled in larger business terms or vague terms of defects. And as a result, you could see that when we look at these challenges, look at what we need to address. What testing is basically doing is meeting two different requirements. A requirement of classical coverage, where the system behaves normally in all cases. So it's about requirements coverage with acceptance tests or behavior-driven testing that comes into play. And using combinatorial test design to determine outcomes based on the requirements, the legal combinations based on the pain points, the points of variation, and on the data. And then the next thing that test has to meet is the expected overall behavior against business KPIs. And over here, we would use new techniques like metamorphic testing or data fuzzing to be able to address this situation where you don't have a ground truth, you don't have a test oracle, right? You don't have somebody telling you this is what your system should give you as a response, yeah? And that's where it becomes difficult, situations where it's difficult to determine what the outcome should be. So you need to keep changing your test, you need to keep changing your data, you need to be creating, different kinds of illegal data combinations to find system weaknesses. And that's how you will be able to address the requirements here. And most importantly, when you're doing all of this, you're doing it to be able to say, okay, can Saritha be given a loan or not? Yeah, okay. And is it the right decision? So in conclusion, let's just do a quick recap. When we look at a quality and test approach for AI testing, we are looking at a continuous cycle, a cycle that considers data as tests, provides functional coverage for the model, as well as functional coverage for the system being validated itself. You do testing during the build itself, because here you start creating, understanding, and testing the data itself, right? And you do all of that so that you can create the right data set, the fit for purpose data set that will provide comprehensive testing. And during that point, you are also identifying and building out the path flows, the business tests that need to come into play. You're going to be doing component and integration testing, which means you need to come into that gray space of understanding the model, how it is deployed, how do you call the API, how do you invoke it, how do you feed the data set. And then you go into a pre-prod or a UAT kind of a test where you're putting on a business hat and driving against the business KPIs and outcomes. And across all of this, you're going to be considering different types of data, and this applies, right, to different types of data, different types of input, and different types of testing that you will be covering. So when you look at it, testing with and without ground truth, you're going to be looking at data quality and test combination in conjunction, test data enhancement continuously, model testing itself, business coverage testing across the system, and cut over to production and acceptance testing. And with all of this, you will look at performance, user experience, and overall construct of the business outcomes. Okay. So that's what I have more or less in terms of a quick primer in terms of why AI testing is important and what is it that you would do as an AI tester. So what are the skills that you need to develop? What do you need to learn further? If you are already a manual tester, what can you do to improve and get into the space? One of the things that I would recommend, and this is irrespective of whether you're doing AI testing or not, is learn automation tools, learn automation solutions, learn a scripting language so that you think about automating first and then testing. Right? It's more important today than ever before because we are looking at such very complex integrated systems, and doing a manual test always will not bring you the efficiency and the speed that you require. Okay. Over and above, learn to write the right kind of tests. Look at this construct, which is called combinatorial test design, which is all about establishing tests, the minimum number of tests with maximum amount of coverage. Okay. And there are free tools as well that you can go and look at, play around, and understand the concept and the construct. The next, when you're looking at it as a specific AI tester, look at their understanding and learn skills around, do a course on data science basics, do a course on how to design statistical tests, right? Go back to school, learn your statistics, understand what it means, right? Learn Python and get some basic scripting skills. And over and above, given the fact that most of these solutions do work with cloud, I think you should get some cloud certification under your belt so that you are familiar with how solutions are deployed as well. You want to be a tester who's empowered, a tester who is capable of addressing different kinds of technical challenges that come about when solutions are being deployed. And so these are skills that you should definitely pick up. And definitely one of the things that, you know, I would assume as testers you do these days is test APIs, right? Test them with automation. And those are core skills that you should anyway have, and they're going to add value to you when you look at testing integrated systems or AI-infused applications. I'll open out. I think I'm pretty much on time. So I'll open out and look at any questions that you may have raised. So for a manual tester to become an AI tester, what skills do I need to focus on most? I think we've already covered that. Learn the basics of data science, learn statistical analysis and test creation, learn Python scripting. Yeah. How can AI enhance online education? And how can AI be integrated into legal systems to accelerate investigation and judicial decisions? So these are functional. So these are interesting questions. They're not purely related to testing, but we can definitely look at it. So with respect to online education, think about it. What are you doing? You want to be able to provide an interactive experience that may be like a teacher who knows you well, right? Who understands the pace of your learning, will be able to structure the courseware, the questions, and guide you as a student through the course content, right? That's the way in which you would look at AI enhancing. So understand the pace and the rate at which the student is learning, provide questions that will allow them to gradually pick up, be able to choose different kinds of complexities in terms of the questions or the pace at which they want to progress, provide them content that is related or relevant. So another interesting aspect is today, there's a lot of what I call as stream of consciousness learning, right? There's this whole construct of mind map. I'm watching a program on TV, or I'm learning, let's put this down since it's all about online education, right? I'm watching a program on TV about wildcats. And I want to know more about Africa. I want to know more about cats in Gujarat, right? The wildcats, the lions in Gujarat. I want to be able to compare and contrast, right? So you understand how the mind is going. So similarly with your online education, I'm learning a physics concept. I want to know how is it in reality, right? What are the safety precautions one needs to take in a lightning storm when I'm learning about electricity as an example. So you need to be able to understand mind maps and provide and provision content that allows people to the student to get a holistic learning, right? So one is in terms of saying, well, can my online education system pace itself with the capability of the student and slowly and gradually encourage and increase the level of the student, right? And next is provide relevant and contextual information, as the case may be, to provide for a more holistic learning experience. Yeah, and then of course provision tests that are fit for purpose and will allow a continuous feedback, encouragement, as the case may be. Can it be integrated into legal systems on accelerate investigation and judicial systems? Now that's a huge topic. I can talk about various aspects of it. There are different things that could come into play, right from even validating contracts, right? Creating legal contracts, to understanding the evidences that are available, using image recognition, using data analytics, using different kinds of text sorting, understanding, bringing profiles, I mean, there's just a lot that we can do there. So I don't think we'll have the time to go into the details there, but that's a space for great imagination and hard solutions. Yeah. Do you have any more questions, or is there any feedback that you would like to provide? You're expected to go into the Google form and provide your inputs or your questions there. The construct is that you're actually using Google Forms to do the interaction here. So Sri Balaji, so I guess we don't have any more questions. So we could conclude the session.
Oh, yes, ma'am. Sure, ma'am. Yeah.
Yeah. So thank you all for your patient hearing. I do hope you found some value to this. If you do need more information, you can connect with me on LinkedIn. And I can also run you through different kinds of solutions that we are actually building out. I've purposely kept this session very generic, not IBM specific, but we have some amazing solutions and technology that I can guide you to if you connect with me on LinkedIn. Thank you all, and happy learning and transforming to AI testers. Cheers.